In this video, we will show you how you can generate synthetic data in Omniverse Replicator using YAML-based approach. Omniverse Replicator is a core extension of the NVIDIA Omniverse platform, and it allows developers to design synthetic data pipelines and generate data from 3D simulations for computer vision models. The data generated from Omniverse Replicator can be used in many applications, from visual inspection to training robots and autonomous vehicles. Developers can use Omniverse Replicator and USD APIs to programmatically interact with the USD files within Omniverse. Here we have a simple warehouse scene with shelves, boxes, and other items typically found in a warehouse. Replicator provides a programmatic way to create synthetic data with various annotations such as depth, semantic and instant segmentation, bounding boxes, and many more. These annotations can then be used by downstream machine learning model training process. Developers can programmatically interact with the 3D scene to create diversity in the dataset, such as the location and the poses of different assets. In this example, we are using a simple Python script to iteratively change the location of forklift, cones, and wet floor signs in such a way that they do not collide with each other or with the racks and shelves. Now let's see what this Python script does. First, we grab the warehouse, cone, and wet floor sign 3 assets from the nucleus server. We then group them by their semantic labels. After that, we randomize on every frame using onFrame trigger. First, we randomize the pose and the location of the forklift using scatter 2D function in such a way that it does not collide with the racks and walls. Similarly, we also modify the pose and location of the cones and wet floor signs such a way that they do not collide with the racks and walls as well. Now let's see this in the action. I'm executing this Python script file by click on Run and then click on the Preview button. Every time I click on the Preview button, Replicator is executing one on-frame trigger to randomize the location and the pose of forklift, cones, wet floor signs in a plausible way, in such a way that they do not collide with the racks or the shelf in the scene. Up until now, most developers who use Omniverse Replicator had to learn Omniverse Python-based replicator APIs to generate synthetic data. In order to further simplify this workflow and help AI developers to use 3D workflow more efficiently, we have developed a YAML-based addition to this workflow. Now, let's look at the YAML version of this Python script. YAML is preferred by many developers today as it abstracts away the complexity of learning new coding language. We have converted the same Python script in a YAML form here. As we did with Python script, we group our 3D assets and assign them the semantic labels, and then we define different randomizations in a descriptive form. We can use it now to do the same task of moving forklift, cones, and wet floor signs as we did with the Python script. Here we have provided YAML file to the parser built in the Omniverse Replicator to run the same simulation that we have built with the Python script. As we click through the preview button, Replicator graph is executed every frame. Every frame, the location and the pose of forklift, cones, wet floor signs change as per the distribution provided. YAML form of parameters makes it easier to track synthetic data generation parameters as a part of the model creation and performance lineage, empowering the true data-centric model development approach. I showed the entire workflow using Omniverse user interface. You can also run this same workflow through the container in a headless mode that is available for download from NGC. All the relevant instructions are available on the same page as well. To get started with Omniverse Replicator, simply head over to our product page for more details.